Welcome back to the second video for Tech 240 on Wednesday, February 3rd. The purpose of this video is to give you an introduction to using relays in TinkerCAD and in the process to help you out with Lab 6. I think if you follow along with this video, then you'll be pretty well set up to do Lab 6. So the first thing I'm going to do is go through page 41 with you in the lab manual. So we'll talk about the different connections on the relay, and we'll talk about this ladder electrical diagram on page 41 in the lab manual. And then I think what I'm going to do as an example, I'm going to put that ladder electrical diagram on page 41 into TinkerCAD, and I'll show you how we would do that. And in the process, you'll see how we use relays in TinkerCAD. So let's go ahead and get started, and I'm going to switch over to the document cam to talk through page 41. All right, so this is page 41 of your lab manual. And the first thing that we need to make sure we're familiar with is the double pole, double throw relay in TinkerCAD. And this is pretty realistic. There are different kinds of relays. One is the ice cube relay that I showed before, but probably even more common in industry than an ice cube relay is one of these little prismatic relays that are like in a little black box. That's really what it is. It's like a little black rectangle. In reality, most of the time, these relays, these electromechanical relays, are probably 3/4 of an inch this way by maybe 1/2 of an inch this way by maybe 3/8 or 1/2 of an inch tall. So they're pretty small. And they are electromechanical, which means there are moving things in here. There's this switch and this switch, two of them, that move. And you can hear them click, actually, when they are activated, when the coil energizes and the switches change position. So it's important to know how to connect these in TinkerCAD. So first of all, there's going to be a connection right here and 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 here. So these are the spots where you're going to have to connect wires in TinkerCAD. It does no good if you run a wire, right there or right there. TinkerCAD won't recognize it. So you got to get it to these pins. You'll see once you start playing around with TinkerCAD. So pin 16, that's the positive side of the coil, and pin 1 is the negative side of the coil. That'll go to ground. And then pins 4 and 13, these are our common connections. Right? These are our inputs to our switches. 13 is the input to these two, 9 and 11. 4 is the input to these two, 6 and 8. And then 6 is the normally closed connection from common pin 4. And pin 11 is the normally closed connection to common pin 13. And pin 8 is the normally open connection from common pin 4, and pin 9 is the normally open connection from common pin 13. All right. So these, excuse me, these three represent a single pole double throw switch, and these three represent a single pole double throw switch. And combined, it is a double pole double throw relay. Okay, so that's really important to understand, or else you're going to get frustrated when you start just randomly connecting wires in TinkerCAD. So I think what I'm going to do as an example is do this one in TinkerCAD. And I think that'll be a very good preparation for you to do Lab 6. Okay, so the first thing that I already realized after just briefly playing around with TinkerCAD is we're going to have to change that just slightly. That's going to have to be 12 volts. Just the way that TinkerCAD has their components set up, that's going to have to be 12 volts. If it's 24 volts, then you can play around with it, but it's going to show that things explode in TinkerCAD. So to make everything work out all right, just change that to 12 volts, and that'll be totally fine. Okay, so just think about what's going to happen in this circuit. Okay, first of all, we haven't talked about this yet, and this is called a selector switch. It looks kind of like this. This is a selector switch. It's a really good fidgeting device. That's partly why I keep it in my office, because I'll be on Zoom calls or meetings or something like that. And as long as I'm on mute, I can just sit there and switch it back and forth. And it's just kind of addicting to have something to play with. So anyway, this is a selector switch. It doesn't have a normal position, so it doesn't spring back or anything. You move it to a position and it stays there. So that's what a selector switch does. Typically, one side of the selector switch would be designated as the on side and the other would be the off. So the way you draw this is with 4 connection pins, and that's actually true. This selector switch has 1, you probably can't see them very well, but there are actually screws in here. 1, 2, 3, 4. These 2 screws right here are actually missing, so you can't see those. But there are 4 connection screws on a standard selector switch. So when it's on, these 2 pins are connected. And when you move this to off, this whole thing moves down. And when it's in off, then these 2 are connected. Right? These 2 these 2 screws or pins are connected. Okay, so basically the way it's drawn here, the way it's going to work is when it's on, we're going to have continuity through here, through this rung. When it's off, we won't, because there won't be connection from here to here. Okay, so when it's off, I like to start actually when it's off. So let's say we've got 12 volts applied here, but we're not turning this to on yet. So this is off, okay? So we don't have continuity through here. So CR1, that's the coil of control relay 1, is de-energized. And when it's de-energized, then all the normally open contacts are open and all the normally closed contacts are closed. So they're in their as drawn state. So this remains open and this remains closed. And if this is open, there's no connection through here. And if there's no connection or continuity through here, current can't get through here, and PL1 remains de-energized. Meanwhile, this normally closed connection does have continuity through it, and PL2, therefore, is energized. And then make sure you get your wires back to 0 volts or ground. Okay. All right, so that was when it's off. Then when it's on, when the selector switch is in the on position, then our coil of control relay 1 energizes. And remember, the plunger moves inside the solenoid, which changes the position of the switch. So now all of our normally open contacts close and all our normally closed contacts open. So now this one closes, which means I have continuity through it, which means PL1 energizes. And this normally closed contact opens, and so I don't have continuity through here, so PL2 turns off. So in summary, when the selector switch is off, CR1 is de-energized, the coil of CR1 is de-energized, and PL1 is off or de-energized, and PL2 is on or energized. Then when the selector switch is switched to on, then the coil energizes and these change state, and so PL1 is on or energized, and PL2 is off or de-energized. Okay, so that's how it works. It's helpful to get a sense for what this is going to do before you try to wire it up. This is our ladder electrical diagram, and now we're going to put it into TinkerCAD, which is more of a wiring diagram, because the wiring diagram actually is going to tell us which pins, which specific pins we are connecting the wires to. Okay, so I'm going to switch over to TinkerCAD, and I'm going to put this ladder electrical diagram into a circuit in TinkerCAD, and then we'll test it, and hopefully it works exactly like we just described. Okay, I've opened up TinkerCAD, and the first thing that I want you to make sure you do is change the file name to your last name space lab space, in this case 6. This is not actually lab 6 that I'm gonna build here, but when you do it, you're gonna do lab 6, so change it to lab 6. I've gone ahead and pulled all the components out here in my workspace just to save some time. Remember that if you're not seeing all the components, make sure that you have all components selected in the drop-down menu, not just the basic components. And the components that I have pulled out are a double pole, double throw relay. It looks like this and looks just like the one that we talked about on page 41. And also two kind of dumb incandescent bulbs. I'm using incandescent bulbs because they're dumb and it doesn't matter if I have a series resistor to protect them or not. They're pretty easy to work with. However, as we're talking about that, I'm reminded that one thing I did have to do was change the voltage of the power supply. So remember, we had to change this to 12 volts. And, oh, the last thing I need to mention is this switch down here. Now, TinkerCAD doesn't have a selector switch like this, but they do have something that is almost the exact same thing, and that is a slide switch. So the way this works is let me go ahead and run it. So now it's running, so it'll move. So now if I click on this switch, it'll change the position of the switch. So when it's like this, these two terminals are connected and these two are not. And if I click on it to move it to that side, now these two are connected and these two are not. Okay, so it functions more or less just like a selector switch, but it's not. It's a slide switch. But it'll work just basically the exact same way. All right. Note that for Lab 6, you don't need a selector switch or a slide switch. You just need push buttons. So for Lab 6, just use push buttons. Okay, now I'm going to start putting things together. And one thing that you'll quickly see is all of the ways that you can mess this up. It's really, really easy to just get something really, really close and your wire is right next to where it should be. But if your wire is not exactly where it should be, then the whole thing is not going to work. So there are a lot of different ways that you can potentially mess this up. So it just takes a little bit of practice. And like I was saying earlier, slow is fast. So I promise you, the more carefully you go through this, maybe painstakingly even, probably is going to save you time in the long run. Okay, so I'm going to go ahead and start. I'll go ahead and start by placing my relay. And these relays and these breadboards are designed to work together pretty nicely because it just fits just right. If I put it right here, now I can connect to this terminal 16 by putting a wire anywhere here. And I can connect to terminal 1 by connecting a wire anywhere here. And then terminal 13 is anywhere here. And then terminal 11 is anywhere in this column. Terminal 9 is anywhere in this column. And 8 in this column. And 6 in this column. So they're designed to fit nicely together. Okay, so I've got that. And then I'll put my slide switch. I don't know, maybe about there. Yeah, I'll go right there. And I'm gonna leave my light bulbs out here. I'm just gonna leave them right here, and I'm gonna call the top one, makes sense to call it PL1, and the bottom one I'm gonna call PL2. Okay. So I've got all my components placed. Now I'm gonna start wiring stuff up carefully. Okay. So I'm going to go from the positive side of the power supply to the positive rail here, and then make it look a little bit nice, because the nicer you make it look, the easier it is to see what you're doing and what you've done. And if you make a mistake, it's easier to track if you can easily trace the wires. If you make a big bird's nest, then it's pretty hard to troubleshoot. All right, now I'm going to keep one eye on my TinkerCAD circuit and one eye on my ladder electrical diagram. All right. So the first thing, I'm looking at the first rung. I'm going to go rung by rung. Okay. And that's the way I'd recommend you do it. First, just look at this first rung and complete this first rung. And within that rung, the first wire we got to look at is this wire right here. That goes from 24 volts, that's the positive side of the power rail, to the common or the input of our slide switch. All right, so go rung by rung in your ladder electrical diagram, and then within each rung, go left to right. That's the way to keep things organized. Otherwise, you will, I just about guarantee, you will mess something up. I would, for sure. All right, so I'm going to go from the positive side of my power rail to the common of my selector switch or my slide switch. And now I've got this wire taken care of. And the next thing I'm going to do is go from the output side of my selector or slide switch to the input side of the coil. All right, so the output of my selector switch, I'm going to use this side. It doesn't really matter for my slide switch, but I'm going to use this side, and I need to go to the input of the coil, right? The positive side of the coil. So that is going to be pin 16, which is right here. So to make that connection, I can use any connection here. So why don't I go from here to here? All right, and I'll make that red too. All right, so now I just did the middle wire. That's this middle connection wire for the top row in my ladder electrical diagram. And the last wire here goes from the output of the coil to ground. And ground is the negative rail right here. So the negative side of my coil is this connection. So anywhere up here will work. So I'm going to go from here to the negative side, and then I'm going to straighten it out a little bit. Okay. All right, and that should be it. All right. So you know what I like to do? Whenever possible, I like to test parts of the circuit individually so that I know if they're working or not. So right now, I can actually get a pretty good sense. My light bulbs aren't going to light up. I have no connections. But if I start the simulation, then right now you can see that there's nothing connected to this terminal. So there's no current going through here. But if I switch this, there we go. So I switched that. Now there is current going through that coil, and that coil is a little bit of a load. And so I get some measurable current going through there. I have a complete circuit, you know, so I get some current going through there. It has a finite value of resistance as well, so it's not infinite amount of current. But I do measure some amount of current going through there. I can see that right here from the power supply. So it looks good. It looks good so far. And then if I switch this back, I should get zero current. Because this is an open circuit because there's no connection to this terminal right here. Okay, so far so good. I think the top rung of my ladder electrical diagram is good, it looks like. Okay, now I go on to the second rung of my ladder electrical diagram, and the first wire needs to go directly from 24 volts to the input of CR1A. And the input is going to be a common pin. And the commons are either pin 13 or pin 4. So you can choose which one, doesn't really say or really matter. I don't know. I'm going to, well, I said that this is PL1. So I think I'm going to make the top side be the second rung. So I think I'm going to make these connections up here be the second rung. All right. So I need to go from 24 volts, that's this rail, to the common side of what's going to be CR1A. All right. So the common, I'm going to use this right here, terminal 4. So I'm going to need to take a wire from terminal 4. And I need to go to the positive side, like, go there, okay? All right, and I think I'm gonna make that red to be consistent. You know what I'll do? Maybe, for no real good reason, maybe I'll make all the wires associated with PL1 be orange? Yeah, orange. Okay, orange. So all the wires associated with the second rung, that's what I'll do. All the second rung wires are going to be orange. Okay. And so now I got a wire this wire right here from 24 volts to the common of what's going to be CR1 alpha. So CR1 alpha, or A, is a normally open contact associated with this pin right here. It's going to be associated with this common. And so the pin I need to use is the normally open contact associated with pin 4. So which one is that? That is 8. 8. Right. You can see that little diagram right here too. It's smaller, but it's there. So the normally open associated with pin terminal 4 is pin 8. So I need to go from here. So I'll take a wire right here. And now where am I going to? I'm going to go to the input of PL1. And it doesn't really matter with these incandescent light bulbs. They're not polarity sensitive. So it doesn't really matter which one you go to here. Incandescents, they're just resistors. And resistors don't have polarity, and neither do incandescent light bulbs. So it doesn't really matter which one I go to. So let's go here and make that a little nicer. Actually, I think I'll go up like that, actually. Okay, that works. And I want to make it orange. All right, so now I got that middle wire in the second rung. Now the last wire goes from the other terminal with PL1 to ground. So I need to go from here to ground. So you don't have to do the wires like I've done before. You can kind of make them straight as you're going if you know what route you want to take. So I'm going to go like this over here. I know I want to go to the ground rail. So I'm going to go like that. Yeah. All right, so I think that should work. All right, so let's go ahead and run it. So when the slide switch is in one side, this should light up. And when it's on the other side, it should not light up. Okay, so let's see what happens. Cross my fingers. Actually, sometimes, to be honest, I kind of hope that I do something wrong because it's a good demonstration tool for me to show you how I screwed something up. So let's see if I got something right. So if I switch this over, PL1 should light up. Hey, good. Okay, good. I mean, I'm kind of glad that it works. That's nice. Okay, so I stopped the simulation, and now I'm ready to go to the third rung. And the first part of the third rung means I have to go from 24 volts directly to the common of what's going to be CR1B. So I'm going to go from 24 volts, that's this rail down here, to the common, and this time I'm going to use this common, the other common, which is terminal 13. So I need to go from one of these to the positive side right there. Okay, and for this whole third rung, I'm going to use a different color. And let's see, is turquoise good? Can you see turquoise? Maybe you can see blue better. Yeah, you can probably see blue a little better maybe. So I'm going to use blue for the whole third rung, just to make things easier to see. All right, so we just did this first wire, 24 volts to the common. And now we need to pick the normally closed contact associated with that common. So what is that? So we need the normally closed contact associated with terminal 13, and that's going to be terminal 11. I'm looking at page 41, but you can also look at it right here. It's this one right here. This is going to be the normally closed. So I need to go from any of these in this row, so I'll pick this one. And where do I need to go? I need to go to the input side of PL2. So once again, it doesn't really matter which of these connections I make. All right, so how do I want to make this? I want to make this, okay, that's fine. It doesn't matter, but, okay. I didn't really need that. Okay, so what I'm going to do, actually, I'm going to go from here. Yeah, okay, that's a little bit nicer. I'm going to go from there, and I'll just make that connection right like that. So that's going to be blue. All right, so that is that middle wire on the third rung. And the last one is from the other side of PL2 to ground. All right, so that should be, I think, all the wires for this ladder electrical diagram. So the moment of truth is when I start the simulation. So when I start the simulation, one of these light bulbs, I don't remember which one, should light up. And then when I move the switch, the other light bulb should light up. And the first one should turn off, right? So as I switch this back and forth, then one light bulb should turn on, the other turns off, and then they should switch. So let's see if we did everything correctly. Oh, so far so good. So now I'm going to switch it. Yay! All right, good. All right. So now you can take a few minutes and you can appreciate the results of your efforts. It's kind of rewarding. I really think it is. It's kind of rewarding, kind of nice. All right, but I won't spend any more time doing that. So let's stop the simulation there. Let's go back to Lab 6 and talk through this real quick. The good news about Lab 6 is it's only one circuit. This is it. So once you program this and put it in TinkerCAD and you answer these questions, that's all there is to it. There isn't even a backside of Lab 6. So first of all, make sure that you change the file name to your last name and then put this into TinkerCAD. Step by step, rung by rung, I would recommend going wire by wire. So just like we did in that example, I would recommend start out by putting in your power supply and your power rails, 24 volts and ground. And then think about this wire right here. You got to go from here to here. So just do this wire right here first. And this reminds me, there is actually not a normally closed push button in TinkerCAD. So this is a little bit unfortunate, but I think what we're going to do instead is we're going to replace that with, let's replace it with a slide switch. So I know I said before that we weren't going to use slide switches in Lab 6, but I realized, there's no normally closed push button, so we need to do something. So let's replace it with a slide switch. That's fairly realistic. I mean, this would be kind of like an electrical system where maybe the slide switch, one side of the slide switch says run and one side says stop or something like that. So that should work. Just have one side be designated as the run side of the slide switch and the other designated as the stop side of the slide switch. I kind of like this better because this sort of more closely resembles like an emergency stop switch where, you know, it's like a big red button sticking out and you hit it and it stops the circuit and whatever's going on, it stops it. But this is okay. This is an okay solution also. So you need to make note of that. Otherwise, you're going to be looking for this component for a long time. So anyway, do this wire first and then look at this wire from here to here. Then think about this wire going from here to here. So look at that. You got two wires coming from this terminal right here. This is one terminal, and you're going to have two wires coming from it. One to here and one to here. This is the common side of one of the contacts, right? This is a common, and this is also a common. Also note that this is the first normally open contact associated with CR1, and this is the second normally open contact associated with CR1. So these are different contacts. You shouldn't be using the exact same side of the relay for both of these because they're different They're both normally open contacts, and they're both associated with CR1, controlled by CR1, but they are in fact different contacts. You know that because that's the first one and that's the second one. So use the two different sides, the top and the bottom of the relay. All right, so then you do this wire here to here, and then this is a wire from here to here, and then you get a wire from here to here, and then you got move on to the second rung. Maybe use a different color if you want to keep things straight in your head. Make a wire from here to here, and then a wire from here to here, and then a wire from here to here. Okay. So this whole thing, here's a clue. This whole thing should include how many wires? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 2 more to go from the power rail on your breadboard to your power supply. So if my calculations in my head are correct, actually I don't even remember what I said before. What did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 2. Unless I'm forgetting something, I think about 11 wires is what you're going to need to complete everything for this lab. Okay. Make sure you include your screen capture at the end after you've built it and tested it, and make sure it works. And then this is the note I was making to remind myself to discuss that when you put this light in here, it's a pilot light, call it PL1 or something. Use the incandescent, and to make sure that that works, change this to 12 volts. All right, so make sure you change that to 12 volts and change that to a slide switch. Okay. And then what you should do is draw the TinkerCAD circuit. So this is more like the wiring diagram. Might be a good idea to do this before you put that into the TinkerCAD program. That might help you. And then what I want you to do is describe here what's going on in the circuit and how it works. Okay, that's going to be it for Lab 6. It is due on February 10th by 11:55 p.m. If you have any questions about this stuff, get in touch with me. Either shoot me an email or come to my office hours. Those are probably the best ways to get in touch with me. I'd be more than happy to help you out if you have any questions. Have a good weekend, and I'll see you next time.